Okay, hello. This is the Unit 8 MCQ test corrections. Here I got 4 wrong, 6 out of 10. Here number 1 you have 3 cylindrical containers are filled with water to the same height. Container A is open. Container B and C are closed, made of the same material with the same thickness, and rest on top of the surface of the water. Assume that the cap makes a seal with the edges of the container. The frictional forces between the cap and the container are negligible. The diameters of container A and B are equal, while the diameter of container C is greater than that of A and B, which the following compares the absolute pressure of the three at the bottoms of the containers. Okay, so I don't know how it got. Okay, so A should be higher than B. Nope, I guess not. Um, yeah. What's the following? The absolute pressure at the bottom. So since A doesn't have the cap, that's not being it is being affected by the atmospheric pressure. Like you have to consider that. And then since B and C are closed, and then the height is like basically the only thing that matters for pressure. We know that at the bottom they should be the same. So we know so we know it's already this one because it's the only one that has where they're both the same, and then A is different. But I thought since A is yeah, so the reference pressure is atmospheric pressure. And the pressure at the bottom is equal to this plus this. I didn't know about this cap stuff. I thought since there's a cap, um, huh? Okay, I think since it's not like connected, like the cap is like laying on top of the water. So you also have the pressure from the cap as well as the atmospheric pressure. So that's why it's greater. Oh, since it's not connected, so then since it's not connected, that means the atmospheric pressure is still affecting the overall system. And then, but these two also have the cap, and this one doesn't have the cap, so that's why these two are equal and greater than this one, because this one doesn't have the pressure from the cap as well. Okay, so that's why it's this one. Okay, then next question. Two identical blocks, 1 and 2, are attached to springs suspended from the ceiling. The blocks are submerged in different fluids, as shown. Block 1 is submerged in a fluid 1 of density P0. Block 2 submerged in a fluid 2 of density P0/2. Fluids 1 and 2 exert more force of magnitude. What's the relationship between force 1 and force 2? So, or F1 and F2. What the heck is that? Okay, yeah. So, it should be 2 F2. 1 is. Okay, so if this is if this is half the density, and we know that the Boring force is rho Vg, and this is half rho, then the Boring force should be obviously half. And then I think I just, I just, like, I don't know, maybe my mind just wasn't working, so I just like, okay, so it's 1/2. This is why I choose this one. But then F1 isn't one half of F2. It's double it because the buoyant force is because the buoyant force of the second one is half of the first one. So that means the first one is twice of the second one. So I just had a brain fart or something, and I just forgot to like just process it, and then I think I just went through it too fast. So and that's how I got this one wrong. But it should be 2 of 2 because if it's half the density, then it's half the buoyant force. So that means the second one should be twice the force of the first one should be twice the force of the second one. Yeah. Okay, next one I got wrong is this one. A pipe with a rectangular cross section has width W and height H. The water leaves the pipe with speed V and fills a pool volume V, which of the following expression is equal to the time it takes the pool to be completely filled. Okay. Um. I actually don't know. I think this one I just guessed because I didn't know how to do it. Volume flow rate is equal to V over T A times. Okay, yeah. So this makes sense. The volume is meters times meters times meters. So they just take out the meters times meters, make it meters squared, which is the area, and then you're left with meters or seconds, which is the velocity. So this makes sense. The cross-sectional area through which the water flows is A times W. Yeah. A equals W times H actually. So you get this. So then you just plug in WH into A right here. Then you get V over T equals WHV, and then you just isolate T. Yeah, I think I just got this one wrong because I didn't know how to do it, so I just guessed. And I guessed the wrong one. Okay, next question. An incompressible fluid flows in a clear pipe with circular cross sections whose diameters vary. A small bead with the same density as fluid is inside the pipe, moving along with the fluid at the same speed as the fluid. The graph shows the speeds of the bead as a function of time for the following intervals. Which of the following can support the graph? Okay, so it moves at the same speed as the fluid. So we know that at these points it's moving at this speed. So I put the radius of the section between 2 and 3 seconds is 1/3. Okay, so I thought it was this one, since if the speed is 3 times, then the radius should be 3 times less. So it should be 1/3, and that's why I chose this one. But I guess reality is this one. Okay, this one does make sense because if it's the slowest out of the bunch, if it has the slowest speed, then it should have the biggest radius because of like AV equals AV. I forgot what it's called, but so that's why it should be that one. But I don't know. It is not. It is a cross-sectional area. It's not the radii. Since wait, since the floor, which is product, the area, not radius, but with not is radius not area not affected by radius. If the radius is pi r squared. Oh, it's since it's pi r squared, the radius is not by factors because of the squared. Okay, I see. I just misunderstood. I just didn't realize that. But so I chose this one because I guess I thought that if the radius is 1/3, then if the radius was 1/3, then this should in reality be 9 times the speed, because the radius is squared. But I forgot about that, so that's why I chose this one over this one. But it was this one because if it's the slowest, then it should have the biggest area. Or yeah, which would mean it would have the biggest radius. And those are the ones I got wrong. Okay, thank you.